Okay, bonus lecture. We're going to talk about a bag. So a bag is a certain kind of collection that basically remembers how many times something's been inserted. So it's essentially a dictionary, but the key is the item, and the value is the number of times the item has been seen. So say we're going through a book and we want to read in each word and say how many times the word "and" appeared. So every time we see the word "and," we'll increment the count. So you could do this just with a straight up map, but it doesn't hurt to have the abstraction. Some languages provide it in their standard libraries. Java does not. They choose not to, but that's their choice. Smalltalk, for example, did, I think, if I remember correctly. It's been a long time. Whenever I'm doing something like this, I'm going to make a little test program. Ideally, what I would do is unit tests, but they're a little heavy for doing just a quick video. So bag. I'll make it a class. We could do it as an interface. It really doesn't make a big difference. The class makes sense. So internally, it's going to have a map of whatever type is passed in and an integer. That means that this needs to have whatever. So this is telling us we can have a bag that has strings, or a bag that has integers, a bag that has databases, a bag that has people. It doesn't matter, right? So you could imagine, for example, the people one, how many classes is a student taking? So we could go through the course lists and add every student into the bag by their student ID, say. And then when we're done adding them all, the integer here will be the number of times a student has occurred in any classes, right? So say they're in 4 classes, the number would be 4. If another student's in 1 class, the number would be 1. I don't need a constructor because I'm going to always declare the map to be like this. So since it doesn't depend on anything coming into the new. Since it doesn't depend on any of the values coming into the constructor, I don't make a constructor. I just use the instance initialization block. I'm going to add, even though it's a map abstraction, we're not going to be treating it as a map per se. We're not going to implement a collection because doing that would actually give us a really weird interface. We'd have to conform to what the interface wants, and I guarantee we're not going to do that. So we're going to add the value. We can call that key. And we should be able to say get, which will not get us the value back, is why I'm saying it's kind of weird from that point of view. It'll get us the count back. Right? So what we need to say is we're going to do this put if absent. And I'll explain why in a second. Now, put if absent takes the key, and it takes 0, because we've seen it 0 times. Sorry. Final int. I'm going to actually make an int. Int's fine. Yeah. So we put the key in and we put in 0 if it's not there. So if it's already there, we don't do anything. Otherwise, we set it to 0. And then we get the key and put it into the value. So that will, if the first time it'll get 0, right? If we'd put it in 10 times, now if we'd done this 10 times, that value coming out of it would be 10 instead of 0. And how it gets to be 10 is like this. What we're going to say is we're going to do map.put value plus 1. For the key. Right? So we're basically saying if it's not there, make it 0. Otherwise, and then no matter what, get it. So it gets 0 or what was already there. And we're just going to write over it with the value increased by 1. I guess we can also then add a remove method. And we'll do this a little bit different. So we need to see if it contains the key first. So if it contains the key, then we're going to get the value. And we're going to put the value of -1. And actually we can optimize this slightly. We can say if the value equals 0 or equals 1, then we're removing the last one. Otherwise, and this is where things become it's hard to write slow code, but you can do little optimizations without thinking too hard about it. It's probably more likely that the value will not be 1. It'll probably be something greater than 1. So if the value is greater than 1, we're going to remove it. Otherwise, the less frequently used one, we're going to do map.remove the key. So when we go to remove the key, so we put in the word and we want to remove it. So and's in there, it's got a count of 1, we'll say. Or let's say it's got a count of 2, right? We've seen the word and twice. We're going to come in here. Does the map contain the word and? Yes, it does. Get the value out of it. That's going to return 2. 2 is greater than 1. Great. So we're going to decrement it and make it now have a value of 1. When we call remove again, it's going to say, is remove in here? Yes, it is. It's going to get it. It's going to have a value of 1. So it's just going to remove the key. When we come in the next time to remove it, and will not be there, so it won't do anything. So add, remove, and get. Get or default. So get just gets what's there. Right? It's guaranteed to be there. Get or default for us will be, we're going to pass in the key and we want to return 0. Because by default, if the thing isn't there, it will have a value 0. If we didn't have that, what we'd have to do is, and the same with the code above here, we'd have to write much more complex code, something like this. I'll just comment this out for the moment. We'd say, well, we couldn't make this final anymore. We'd say value is assigned map, get key, so we get the key out, if, and that's going to crash if we don't make this an integer, because the auto unboxing, we saw that in a previous video. If value equals null, value is assigned 0, and then we'd return the value, right? So that's a heck of a lot more work than just this. And that's essentially what get or default will do internally. So it's nicer code for us. So that's it. Let's code it up. Let's try it out. Okay, so it's unhappy. Why is it unhappy? Pause the video. Think if you can figure it out. Okay, it's unhappy because bag uses a generic, and we are not passing it the generic. So like a bag of strings. Now it's happy. So it should print out 0 followed by 1 if we've done everything correctly. Zero and 1. So if we add another one, it should be 2. And if we do, remove, it should go back down to 1. Helps if you spell correctly. Right. And do it again. So we added it once, we added it twice, we removed it once, removed it twice, so it should return 0 for the last one. Now, is that correct? That was, so we had none of them in there, so it did 0. We added 1, and we got it out, we got 1. We had another one, we got it out, we got 2. We removed 1, we got 1. Moved another one, we got 0. If we remove one more time, shouldn't blow up. It should just print out 0 twice. There you go. And of course we can do like add lowercase hello down here, and now it will not go up to oh, I was removing hello. So I meant to add, but so I removed something that didn't exist, and it didn't change the number there. I meant to do add lowercase hello. So that's good, but there's a couple of things that I probably want to do. I probably want to make another public. I don't know the type yet. I'm just going to put object keys. So map.keys, key set. Right, so map key set. So it returns the set of keys. Remember, the keys have to be unique, so we would use a set. So we're going to return a set of t. Now you'll notice that this set had a set of k, right? Because the map has two values. Remember, it's got the key, which it calls k, and the value, which it calls v. We only have one thing, we're making it t. So the names do not have to match. So the keys are quite useful because that lets us see. Now, if we were to so we do this, we should see what keys are in there, hello and lowercase hello. Okay, so there we go. Which lets us now do something like we want to iterate over the bag, right? So what we would normally say is something like this. So normally do something like this. Okay, I could do that, and then I could do system.println and bag dot get the key, right? So we're going to get the list of keys, hello and hello, and we're going to print out how many times each thing is in there. So there should be 3 capital H's and 1 lower h. 3 capital H's and 1 lower h. And I could make that a little nicer. So I do that with the keys, but I might not want to do that. I might just want to say I want to go through the bag, which is what I do with a list, right? So that becomes a little more complex. And bear with me because I have never done this one before. I don't think. Maybe I did it once. So this needs to implement iterable of t. So remember what iterators are. There are ways to go through things efficiently. So here I think all we need to do is return map.key. Oh, actually, that's not going to be quite right. That's going to be more complex. Wonder if I can get away with this. So what I'm intending to do is, so now because it's iterable, I can do this. And I just want to, actually, this is going to be interesting. It's going to be, what I really want to get out of here, and this is where you have to think about things, what I want is some sort of entry with the string and the integer. Entry, we don't know what that is. It's actually going to be part of our bag, so it's a bag.entry, which we'll have to make. That's going to be an inner class, nested class. And we're not going to have to call get anymore. That's the whole point. What we're going to say is entry.getKey. So it's going to have a bunch of keys and values. So we no longer have to do the lookup. It's getting it out all at once. I'm not 100% sure how I'm going to solve this, but let's give it a try. And actually, I don't need this to be, it is just an entry of string. And I'm not going to make this static then. Maybe it wants it, maybe I'll make it static, we'll see. And so this is actually going to return an iterable of entry t. Might have to be bag.entry t. Told you I've never done this before. This is new. So that got that working. So now we're returning an entry. The bag iterator is returning a bunch of bag entries for the string. And we need the get key and the get value. Just for now, I'm going to return null and 0. This is not happy because it's not an iterator. That's not what I want. I want an iterator of bag.entry t. Right, because now it's happy about that. Hopefully main is still happy. And this should be entry, not key. So now main's happy. So the thing's set up correctly with the with that, and this is all set up correctly. So now it compiles, but it's not going to work, right? Because I'm returning null and all that, it's going to fail, right? Null pointer exception, just as expected, because this thing here return null, and we're trying to call the this winds up being, this is another one of those syntactic sugar things where it does hidden method calls on us. So it's ultimately calling the iterator, right? When we call bag, it's really calling bag.iterator for us. And then it's going to do, call the has next and all this kind of fun stuff. So not a surprise this fails when you do that. So I'm not sure if this was actually a good idea, but I'll slug through to the end. So for this to work, I need to make, I think, a list is going to be sane. A list of t. No, a list of bag dot entry t. An array list. Okay. And we can probably do map dot size. Not sure what that returns in the case of a it returns a number of key value mappings, which is what we want, right? So we can, remember that an array list, the array grows as needed. Because we know how many items are in our map, we can do this thing where we just pre-allocate the right amount of space and it doesn't have to grow. So a little bit more efficient, right? So again, this is one of those cases where if you know a little bit of how the API works and you don't code very poorly, you can make a couple of little decisions here and there that impact the speed of the code. That's one of them. It is generally hard to write bad code, slow code, but there are a few things you can do to speed it up. So what we're going to do is we're going to do essentially what we did before. So I'm thinking this may not have been the best idea, but it does show you how the iterable, iterable and the iterator and this thing can be used if you really want to make it work that way rather than what we were doing. So what I think we're going to do is we're going to go through here and we're going to go get a map.entry. The t and integer. And we're going to take our map.entry set. So this works really similar to, so that you see they didn't do it with map, what I'm trying to do here. So they made you do this entry set thing. So maybe that's what I'm thinking. This might have been a bad design choice, but again, I'm invested now. So at the end, we're going to make a list of all these entries and going to return the lists iterator. So what we're going to do is we're going to call this map entry actually. And I'm actually going to rename this from list to entries. I like that better. So I didn't add a constructor that took what I want, so I'm going to have to add that. And that'll be the entry dot get key and the entry map entry. So I'm going to take it back when I said that map did it this way. Remember, we're not trying to be a map. We happen to be using a map. We want to be actually more like a collection. So we want to be iterable. So I'm going to add a constructor here. its entry. To make variables for the key and the value. We don't want them to change, so make them final. We'll return the key. We'll return the value. Okay, so what we've done is we've taken the map, gotten all of its entries, which are the key value pairs, right? Key value pairs. And then we've put them into a list. I haven't put them into the list yet. So we put them into the list, and then we return the iterator for the entries, which means when we come back here, what we're getting is a iterator of these entries, which is each of the entries with their key and value pairs, the key being hello or lowercase hello, and the value being 3 or 1 in this case. And let's go ahead and add evil world. Apparently the world's very evil. So let's see what happens. Worst thing that happens is it blows up. So hello. So world appeared once. And hello appeared 3 times. Lowercase hello appeared once. And evil appeared 1, 2, 3, 4, 5 times. So it's correct. I don't like the fact that the keys are coming out in a weird order. So I'm going to make one minor tweak, which is my map. I'm going to make a tree map. Now remember, there's a reason why I declared my variable to be a map. Here I'm using a tree map. What's its unhappiness? It probably wants me to just do the assignment up here, which I don't like doing. But, oh yeah, so I want to move the assignment to the field declaration. And yeah, no, I don't want to do either of those things. So I'm happy the way it is, I think. So let's see what happens. So now we get them alphabetically. If we don't like that alphabetical thing, we can, again, in here, I think there is the ability in the tree map constructor to pass in a comparator, right? So we can do a case-insensitive comparison if we wanted to. There we go. If we instead wanted to return it in the order of the values, things get a little bit more tricky. We could try and do that. So I wouldn't make that a tree map anymore. I'd make it a hash map. Again, hash maps are quicker. And I don't need it sorted, so hash map's fine. So once I've added the list here, I'm going to call collections.sort, which again sorts the list in place. So I want to pass in the entries, and I need to pass in a comparator. Now the comparator takes 2 things, A and B. So we're going to get the value, A.getValue is greater than B.getValue. So that's not the way that works. It returns a negative number, so we'll just subtract one from the other. See if that works. Like I said, I always get these things backwards, so odds are it'll sort low to high, and I want high to low. What did I tell you? So all I have to do here is say B and A. And I'll explain how that works in a second. because it's a lambda, I can do that. So b get value, that's going to return, say, 1, and it's going to return, say, 5. So 1 minus 5 is going to be a negative number, which means that the 1 is smaller than the 5, because if it's a less than 0, that means it's smaller than. And when we get to 5 and 3, 5 minus 3 is 2. That means that we're trying a number greater than 0. Therefore, 5 is greater than 3. When it's doing all the sorting, it's just keeping track of all this stuff. I believe it's a quick sort algorithm underneath, but doesn't really matter. Oh, and apparently there is a list.sort, so we could apparently do entries.sort. There you go. Sometimes the IDE is nice and helps out. And again, think of what we'd have to do if this was an anonymous inner class. It would look a lot worse. It would look like this. That was a mistake. This shouldn't be integer. This should actually be comparing the bag.entry of t. So this should be a bag entry t and a bag entry t. There you go. So do you want to type in, basically, do you want to type in all of that, or do you want to type in that? They're exactly the same. The compilers are going to generate the same code. That seems a heck of a lot better, right? We can keep it for a second and just test it and make sure. It's always good to test things. We wrote it. We should test it. There we go. And run it and test again. So your choice as to how you deal with that. The other fun thing is we just implemented what's called a heap. Priority queue. So we've implemented in a way that is non-standard, but we've got the same effect, right? So a priority queue or a heap or whatever lets you take either you can do a min or a max. You can get the things with the greatest values, or you can get the things with the smallest values, kind of thing. So that's another data structure. I leave that to you to investigate if you want to. You are the first students I've ever shown a bag to. Normally I don't have time to get here. Have a good day.